Hey there, guys. Today we're going to look at function notation yet again. We're going to elevate it just a little bit, so be ready for this. All right, so yesterday we looked at simply substituting a number into an equation. Today we're going to take it to the next level where we're actually going to have multiple equations that we're going to be dealing with. So for this first one, it says g of w. Well, it's actually asking for g of 2 plus j of 1. So we're going to take g of 2 and we're going to substitute a 2 wherever there is a w, and we're going to solve that. So in this case, 4 plus 3 equals 7. So that's g of 2. Now we're going to do j of 1. So wherever there's an h, we're going to put a 1. So we have 1 plus 1, which is 2. Now for g of 2, we had a value of 7. J of 1, we had a value of 2. So what we're going to do is 7 plus 2 equals 9. So g of 2 plus j of 1 equals 9 is our final function notation. Here's another one. So now we're doing g of negative 1. So wherever there's a negative 1 in that, or that w, we're going to substitute a negative 1. Notice I am putting it in parentheses especially because it's negative. Remember, when you square a negative, it becomes a positive. So this would be 1 plus 3, which is 4. Now I'm going to do j of negative 1. So I have negative 1 plus 1, which gives us a value of 0. So then 4 plus 0 equals 4. So g of negative 1 plus j of negative 1 equals 4. So it's essentially the same thing we were doing yesterday. We're just taking multiple expressions or multiple equations and combining them. Now, it's not always addition. Sometimes it can be subtraction. It can even be multiplication, things like that. So make sure you're paying attention. So this one I kind of made on my own. Here we're going to do j of 3. Ignore the 2 for right now. So we're just going to do j of 3. So then we have 3 plus 1, which is 4. So then to do j of 3 times 2. So that means I'm going to be doing 2 times 4, which is 8. So 2 times j of 3 equals 8. I know that looks super tricky, but really all you're doing, so if you ignore the 2 for just a second, and look, you have j of 3 right here. Then multiply whatever you get, your solution times 2. Let's see what we have over here. Okay, essentially the same thing. So we're going to do w. Whoops, I guess I should use a pencil. We're going to do w of negative 1 first. So that means I have negative 1. Whoa. Negative 1 squared plus 3. Negative 1 squared is 1, plus 3 is 4. I think we did this one prior, so that seems familiar. So now we're going to do 4 times 4 because g of negative 1, which is that inside piece, is 4. So 4 times 4 is 16. So 4 times w of negative 1 gives us a value of 16. So once again, we're taking two equations, doing a little plugging and chugging, or using the operations that are given to us. Now this one's a little bit trickier. If you notice, we have a plus 1 inside parentheses. So basically, what we're going to do here is this right here is what we're going to substitute wherever there's a p, because it's saying a of x plus 1. Well, over here is where the letter p appears. So then we're going to do a of, I think I'm x plus 1 equals 2. So wherever there was a p, we're going to put x plus 1 minus 5. Now, if you notice, none of our choices match this, so we have to do some simplifying, and none of them have parentheses. So we're going to distribute, so 2x plus 2 minus 5. We have like terms to combine, so 2x, 2 minus 5 is a negative 3, so that would be minus 3. So then A would be our best choice in this case. All right, here's another one. It says A of P equals 2P minus 5, which is the one we just used, but now it's saying A of P equals 21. So instead of A of P, we're going to put 21 in its place and then solve for B, or P, I'm sorry. 21 equals 2P minus 5. So again, we took this and substitute 21. And now we just have a two-step equation. So we have 26 equals 2P, dividing by 2 on both sides. So P equals 13. So essentially what we have here is A of 13 equals 2 times 13 minus 5. So 26 minus 5 gives us that 21 that we were starting with over here.